This is Geometry Lesson 10-10. We're on equations of circles, and the first thing that I want to do is investigate what this equation looks like using Desmos. And you probably have a good guess because of the name of the lesson, but nonetheless, go ahead and see what this looks like. So if I come over to Desmos and I type this equation in, I'm going to move this slider for h, and I want you to see what happens. I'm going to first move the slider to the right. Oh, interesting. If I move the slider to the left, very interesting. It seems to be moving left and right. The fancy way of saying that is it's a horizontal translate. What happens if I move k to the right? It goes down. If I move to the left, okay, it goes up. Okay, so it seems to move up and down. So the way that I would say that is it has a vertical translation. And then what about n? Oh, it makes it bigger and smaller. So one of the things that I really want you to pay attention here is when n is equal to 1, what is the radius of the circle? And hopefully you agree, yes, the radius is 1. If I change n to 2, will the radius of the circle be 2? No, it doesn't seem to go all the way up to 2. I'm looking on that y-axis. It goes like to 1.4-ish. Okay, now it hit 2 right there. Oh, when n was equal to 4. Interesting. Well, when does it hit 3, I wonder? So if I just keep scrolling, when does it hit 3? When does it hit 3? Right there at 9. Okay, so I'm noticing that 1, 4, 9 are all perfect squares. So I have a feeling that the next time that I'm going to hit an integer is when n is equal to 16. And I'm going to guess that's when it's 4. So let's move this all the way to 16. And indeed, we get to a radius of 4. And then the next thing that we'd have is a radius of 5 when n is equal to 25. So it seems in order to get the radius, we take the square root of whatever the value of that number is. The one thing I'm also noticing when I'm moving h left and right is when I move h to the right, you would think it moves to the right, but it instead moves to the left. It kind of moves the opposite direction. And same thing with the value of k. You'd think that because k is next to the y in the equation, that k would move it up when I move it to the right, but instead it moves it down. It's also kind of like the opposite. So let's memorize all these things as we go back to our notes. So in our notes, this was the equation that we had, and let me add some stuff to this. So we know that this h right here is moving it in terms of left and right. So I'm going to say this is a move left or right. A good way to remember that is, hey, it's next to the x variable, and the x direction is left and right. That's an unfancy way of saying things. A more sophisticated way, in the way that I want everyone to use my class, is it's a horizontal translation. And I'll make a note here that it's the opposite. AKA, if it's a positive value, instead of moving to the right, it actually moves to the left with a positive value. Okay, what about k? So k, I'll annotate this one as well. This is also going to be moving the circle, and it's moving the circle up or down. And technically, that's also a translation, this time in the vertical direction, so that's known as a vertical translation. And again, that is opposite. So a more sophisticated way of saying all that, or a more simple way at least, is saying that these coordinates, if they are the opposite, is the center of the circle. I mean, look at this. So if I come back over here, the center of the circle is 0, 0 because h is 0 and k is 0. If I change h to be 1 and k to be 2, then the center of the circle, if I graph this, it will be negative h, because it's the opposite of h, right? Comma, and then the opposite of k would be negative k. So let me come back here and type in my negative first, and then k. And this is the point that is the center of the circle. And I can label this the center of the circle. So now if I move h and k around, you can see that the center of the circle is changing by whatever the opposite of the h and k is. Kind of cool. All right, so I'll make a note here that this affects the center of the circle. So center of the circle is k and h. So what about this number over here? So again, in order to find the radius, we have to take the square root of this number to get the radius. So I'll write over here, radius is the square root of whatever that number is. So we can use all of these notes right here and make up our own equation for this. And again, I still want to use the letters h and k because those are the common ones that we tend to use. The general equation of the circle, in order to say opposite just means multiply by -1. For example, if I say, what is the opposite of -7? Well, it's positive 7. What's the opposite of 1? It's -1. Opposite just means multiply by -1. So if I'm trying to say, hey, make sure that this is always the opposite, you can instead now say down here that this is going to be the quantity of x minus h. And this minus sign tells me it's going to be the opposite of what it normally is, and that has to be squared. One of the questions that I get a lot of students asking sometimes is, why is there a plus sign here? Why is there a plus? And to answer that, I can say, well, what happens if I change it to a minus sign? If I change it to a minus sign, I get this weird thing that's called a hyperbola. A hyperbola is like two parabolas away from the center. We study that a little bit more later, if we have time. And then, so a plus sign makes a circle, and if you have if x is not squared, and you just have y squared, then you get a parabola that looks like that or that. If y is squared and if x is squared, then you get like a parabola like this or this. If y is squared and x is not squared, then you get a parabola like this or this. And then the last thing that we have is an ellipse for the conic sections. An ellipse happens when this is unbalanced, like if that was divided by 3 and this one was divided by 4. These numbers not being the same would make this an ellipse. That is on a tangent, though. Let's come back and finish this equation. So y plus k, this is now going to be in parentheses y minus k, because again, that was the opposite of the thing happening in here. And let's go ahead and say this is the thing that controlled the radius. So this is the radius if I were to square it. And I will make a note here to get from the radius to the actual, or I guess get from this number to the actual radius, you'd have to square root as an operation. So to get from here to here, you have to take the square root in order to get the radius. I don't know if that's good enough for your notes. Maybe you want to have some sort of expansion on what that actually means here. All right, so let's go ahead and try some example problems. I have this equation, which I can clearly identify as a circle. I'll never give you an ellipse or a hyperbola or anything else in this class, for this unit at least. In this unit, that's a plus sign, so it's definitely a circle. Okay, so what is the center of the circle? The center of the circle, well, the x-coordinate is not positive 1. It's actually negative 1, because this is the opposite of what's happening here. So I'll make a mark here to say, okay, we're at negative 1. And then instead of going down 2, because y is saying negative 2, right? In terms of the y-axis, I would theoretically go down 2. You do the opposite, and you're going to go up 2 instead, up 2. So if I go up 2 from this spot, I get the center of the circle. And this was just a placeholder value, so I'm going to go ahead and erase that. Okay, so I have the center of the circle. I'm ready to go. And now I need to find what the radius is. So in order to find the radius, I'm going to take 9. I'm going to say that the radius is equal to the square root of 9, which is coming from that number, and therefore it's equal to 3. So the way that I do this is I count up 3, 1, 2, 3, and I make a point. I count right 3, 1, 2, 3, and then I make a point. And then same thing, you just keep making your points 3 away, up, down, left, and right. And then you do your best attempt to make a circle through those points. I know it's hard for a lot of students. If I had to freehand this, it would probably not look the best. Luckily, I have technology, and if I just hold down my shapes using GoodNotes, I can, yeah, that was terrible, but bam, and I've got my circle, which is right about there, and I can move it into the correct spot. So I can say, that is my circle right there. Cool, so I've made my circle. Let's try another one. Oh my God, Mr. Sundell, you forgot a thing. You forgot to say what the number is next to the x. And if you have no number, you assume it is, yeah, you guys got it. It's 0. So it's going to be x plus 0, or you can say minus 0 if you're being cheeky, plus this y plus 1 squared is equal to, technically, I'm going to write 4 squared and just make this super easy for us. The radius, therefore, is 4, because 4 squared is 16. I will always give you a nice perfect square over here. For easy problems, you'll see in the next lesson that I can make things a little bit more tricky. So what is my center? That's usually where I start. So the center is 0, negative 1. You take the opposite of the thing in here, right? So 0, negative 1 is this point down here. I have the center of the circle. And then the radius is 4, because I take the square root of 16 to get to 4. And I'm going to count up 4, down 4, right 4, left 4. Okay, so up 4, right 4, left 4, down 4, and I do my best attempt to go through all of those points at the same time. Technology saved me. Haha, I got a circle. All right, and that looks pretty good, and I just have to move it in the right spot. Yeah, I got my circle. Cool, that concludes the notes for 10-10, equations of circles for geometry. Thanks for watching.